Okay, well, we're in a fix this time. This is problem 39, also on page 538. 538 is just loaded with these problems of solving triangles. Um, so far in this week 12, I've done two problems solving triangles using the law of sines and two problems using the law of cosines. And now here's a problem where you could use either. You just have to use your wits about what makes sense to use. So problem 39, again, is a sister to problem 28, I believe. I'm looking at problem 28, and you know what? Maybe A. What did I say? I'm doing 39. I've got you doing 25. Where's your 25? I think you've got a law of the cosines problem to do. Well, nonetheless, here comes problem 39. Problem 39 says A is equal to 10 degrees. Little a is equal to 3 length measures, and B is equal to 10. Let's draw this. I've got a base angle here. Call it A. It's 10 degrees. Okay. I've got a side across from it, 3, and I've got a side over here, B equals 10. Okay, this is A, and so somehow I got to determine what C is and what side C is. So what do we have here? We've got one of those side angle type problems. So we've got to do some analysis real quick. The first question is A less than, well, is A big? First question is A greater than B? Because if it is, then there's only one triangle. 3 is not bigger than 10. And the answer is no. So we're going to move on. I guess I could draw a little flow chart here to explain that. No, I'm not going to do it. I'm going to hope I have done that in class already. Oh, I just kicked the screen. Everything's good. So move on. The next question is, what about H? So let's calculate H. What's H? H is this guy right here. And so that says that H over 10 is the opposite over the hypotenuse for this angle A. And so the sine of A is this length divided by that length. And so H is 10 sine A is 10 degrees. Let's see what that says. I got a sine and I'm multiplying it by 10 times, and H is not too big. H is equal to 1.74. Okay, so let's now look to see what that means. I think it's bad news. It's bad news because A is bigger than H, and therefore, okay, so there's side H, there's side A. Let me draw it in a different way. So there's side A, a little bit bigger than H, but there's another triangle over here. Okay, so bad news, we've got two triangles to deal with. Let's say here's triangle 1. It's got sides A, B, C, and angles A, B, C. Here's triangle 2. It's got sides A, B, C, and angles big A, big B, big C. Both of them share an A equals to 3. Both of them share B equals to 10. And both of them share an A equals 10 degrees. But you know what? That's all we've got. That's all we've got. So how are we going to find some other sides here? Well, I think the best way to proceed here is to go after this angle C, because you're going to see, there's a lot of puns in this triangle solving. You're going to see that angle C can be this guy or it can be this guy. He can be less than 90 degrees or he can be more than 90 degrees. So if I set up the law, I said C, that's actually B. It's actually angle B. So if I set up the law of the sines for this angle over here, and I use the data that we have, which is sine A all over A, then I'm going to find that sine B is equal to B over A sine A, and I can put that data in. B is 10, A is 3, sine A is sine of 10 degrees, and so sine B is going to be equal to sine A, sine of 10 degrees, times 10 divided by 3. And that's equal to 0.578 and change. I'm just going to take the, I'm just going to take the arcsine. Yeah, I'm just going to take the arcsine, and I'm going to get, I wish I hadn't taken the arcsine. Let me go back. Yeah, 0.57. Okay, so with this, let's let's do this. Let's draw a unit circle, a small unit circle. Let's mark off over here. If this is 1, then this length right here is 0.578. And look at that. There's one triangle, and one angle, and there's the other. All right, this is the angle that is this manifestation of B, and this is the angle that's this manifestation. So now let me calculate what that angle is by punching arcsine. Punch arcsine. Go ahead, I dare you. Arcsine, and what I'm going to find is this angle right here. Right, this guy is 35.368 degrees, okay? If I subtract that from 90, I find this angle from here to here is 54.6, and if I go ahead and add that to 90, seems odd, doesn't it? Plus, then I find that this angle right here, is 144.6. So let's go write those up there. These again are both angle B. One of these, this outside triangle, this is this triangle right here, we're going to call number 1. This triangle right here, we're going to call number 2. So number 1 has got a 35.4 degrees, and the other angle's got the other triangle's got 144.6 degrees. So quickly I'm going to calculate C by adding these two up and subtracting them from 180. So this guy is 134.6, and this guy is minus 144.6 subtract is 25.4 degrees. And now all that's left is for me to find side C, and we're going to do that again. Let's see, what can I do now? I can do side C probably a couple of ways. Here's side C, and I could use law of cosines here. I absolutely could use the law of cosines here because I know this side, I know this side. But let me just use the law of sines for no particular reason. Let me form this ratio right here. So C is equal to A sine C, sine C all over sine A. And since I've got different C's, I'm going to get two different answers here, different C's, different A. So both of these things have a 3, and both of these things have a sine A, which is 10 degrees, but they've got two different sine C's, right? So let me use, let me go 3 inner 10 sine, hey, I turned my calculator off. Oh, okay. 3, enter, 10, sine. I'm going to divide that. I'm going to store that in 0 so I don't have to calculate it again. And now I'm going to use this C, 134.6. I'm going to take the sine of that and I'm going to multiply it. So what did I just use? I used 134. I got 12.3. Okay, and in this other case, here is 3 over sine 10. I've got to use this C, 25.4 sine times, I get 7.4. Do I have the answer looking at me someplace? I do not. I'd have to go look it up. No way we made a mistake. Let's move on to the last problem in homework set 39.